Welcome class to our lesson on symmetry. Okay, what is symmetry? Well, a figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image. Alright, what in the world am I talking about here? Well, let's talk about the word image and pre-image. Now, on the last lesson, we spoke of pre-image being a picture that you start out with, and an image is the picture that you end up with. So, like when we were doing our transformations, like a translation or a reflection or a rotation, whatever we started with was the pre-image. What we ended up with was the image. Now, a figure has symmetry if you could take that picture and, let's say, drew an invisible line, and then on that line you can fold it in which the image will match on top of each other. Here is a good example. Look at this heart. Notice how we have this right side and this left side. And here is our imaginary line. If we can fold this and match this left side onto the right side, then it has symmetry. If you can take an object and draw a line and it will not fold on magically or exactly, then you know it does not have symmetry. So a figure has line symmetry or reflection symmetry if it can be reflected across a line so that the image coincides with the pre-image. So I can match these perfectly. The line of symmetry, also called the axis of symmetry, divides the figure into two congruent halves. Now, just because this one has only one, that doesn't mean that everything only has one line of symmetry, or things that have symmetry has one. You can have other objects that can have more than one line of symmetry. Alright, let's look at this picture. If you want to pause the video and do a quick sketch, I want to see how many lines of symmetry you can draw with this star. Okay, let's see what you got. Here would be one line of symmetry. 2. Notice that I could fold and fold. That's 2. 3, 4. Now if you stopped at 4, you're actually not correct, because if you look carefully, you can actually draw lines of symmetry going in between the star points. So I could actually fold the star here, so that would be 1, or actually 5, 6, 7, and 8. So this star had 8 lines of symmetry to it. Alright, pause the video, see if you can do a quick sketch, and draw how many lines of symmetry this triangle has. Okay. No matter where I try, you cannot draw a line of symmetry. So in other words, this picture cannot be split where you could fold it and match it to on itself. So our answer would be no lines of symmetry. Alright, try this one. Let's see what we get. 1, 2, 3, and 4. So this picture would have 4 lines of symmetry. Now let's look at these 3 items. What I would like for you to do on your paper, label A, B, and C, and then I want you to write down how many lines of symmetry each picture contains. With the first picture, 1, 2. So A has 2 lines of symmetry. Let's look at B. I can't go straight up and down, but what about across the middle here? Yes, I could take this bottom half and match it up with this top half, so this would have one line of symmetry. And then let's look at this flag here, the flag of the state of Ohio. And notice I cannot go diagonally straight up and down, but I could split it right down the middle where I could get the bottom part to match up or coincide with the top. So this one would have also one line of symmetry. Now let's talk about this next type of symmetry, rotational symmetry. A figure has rotational symmetry or radial symmetry if it can be rotated about a point by an angle greater than 0 and less than 360 degrees, so that the image coincides with the pre-image. Let me show you a demonstration of what rotational symmetry is about. So this is how rotational symmetry works. Let's say we have this rectangle, and I make a duplicate rectangle underneath. And notice that these match up nicely on top of each other. Now, let's take the top rectangle and turn it. If you look through the paper, you'll see the second rectangle. But right now, it's not matching up with that bottom rectangle. In order to be rotational symmetry, you have to turn the picture until it matches up with the other rectangle. So as I turn, notice that it matches up. Once it matches up, you have rotational symmetry. However, it has to be less than 360 degrees, but more than 0 degrees. So let me show you what I'm talking about. I am going to put a mark here at this top left corner. Now, in order to be 360 degrees, we would have to turn this all the way around until that arrow is back on top again in order to match. But let's see if it matches before it goes all the way around. So here we go. Turn. Nothing's matching. But now, look what happens. The arrow is now at the bottom right hand corner and it's matching. So, since this took less than 360 degrees, this has rotational symmetry. Now I'm going to show you an example of an object or shape that does not have rotational symmetry. So here I made duplicate triangles, and let's go ahead and match it. Now remember, it's got to be more than 0 but less than 360 in order to get it to match. So what I'm going to do is I'm going to draw this arrow right here, and if it ends up back where this arrow is, then it has no rotational symmetry. If it lands somewhere else, then it does. Okay, here we go. Let's turn it. Now I think you can fairly see the other triangle. It's not matched up. So I'm going to keep turning it to see if I can get it to match. Nope, still not working. Still turning and still not working. Here we go. The only way I can get it to match is back onto itself. So therefore, this has no rotational symmetry. Now look at these three, A, B, and C. What I would like for you to do is write down how many, just tell me if this object has rotational symmetry. A simple yes or no. Can I turn it where it would match exactly onto itself? So everybody look at A. Does it have rotational symmetry? No, it does not. The only way I could get this to match is if I would take this object, copy it, and turn it. You would have to turn it all the way around onto itself. Remember, it's got to be less than 360 degrees. So if you go exactly 360, then it has no rotational symmetry. What about B? Yes. I could actually turn this one 180 degrees and it would match onto itself. What about C? Of course, this one would actually have several turns, in which in geometry you will tell what the degree is, but right now all I want you to do is tell me if it has rotational symmetry or not. Alright, let's look at this slide. Just simple yes or no. Does A have rotational symmetry? Yes, it does. You could actually copy this picture, turn it, and it would match onto itself. B. Yes, this one would also have rotational symmetry. You could copy this picture, turn it, and it should match. Less than 360, but more than 0. What about C? No. This is a scalene triangle, and all the sides are different, so there's no way you could get this to match unless you went all the way around 360 degrees. Now, a couple more symmetries I like to talk about, and this is involving three-dimensional figures. A three-dimensional figure has plane symmetry if a plane can divide the figure into two congruent reflective halves. So in other words, look at this green box on the screen. Notice it has this red looking paper that's dividing it into two parts. If you can take a sheet of paper or any kind of plane and cut right through the middle of it, where the left will look like the right or the top will look like the bottom, then it has what we call plane symmetry. The other one is symmetry about an axis. This means I can spin my object around a certain line. Alright, if I can spin it around a line, which is also called an axis, and I can get it to match, then it has symmetry about an axis. So let's look at this picture here. Does it have plane symmetry? In other words, can I cut it anywhere and get the left to look like the right or the top to look like the bottom? Of course I can. Straight down here, I could take this and cut it, and I could make the left look like the right. Now, does it have symmetry about an axis? Could I spin this pyramid where you could get it to look exactly the same if I could make a certain turn? Yes, you could. So, in this problem, you would have both plane symmetry and symmetry about an axis. Alright, what about this picture? Could we have plane symmetry? Yes. Imagine that this is a piece of paper and we are cutting it straight down through here. You would have this side or this back side would look exactly the same as this front side. So this would have plane symmetry. Now what about symmetry about an axis? Could I spin this around and get it to match? No. So this one would be no symmetry about an axis. Alright, look at A, cone. Does it have plane symmetry? Of course, I could go anywhere I want as long as I cut it right down the middle. The left would look like the right or the front would look like the back. So yes to plane symmetry. Now, what about symmetry about an axis? Well, if I drew an axis right here, I could spin that cone around that where it would look the same no matter where I went. So yes, this would have symmetry about an axis. Now B, this is a tricky one. So what I'm going to do is I'm going to put some numbers in. So let's say this is 6, this is 2, this is 4, this is 3. Now, does this have plane symmetry? Could I cut it anywhere? Of course not. If that's 2 and this is 4, then you know that these two would not match up if you were to cut it down the middle. So no, it would have no plane symmetry. Now, what about symmetry about an axis? So it looks like I could put an axis here, but I'm sorry, there's no way that you could spin this around this line in order to get symmetry about an axis. So that would also be a no. Alright, there you have it, and that is your lesson for this week.